The next topic deals with the natural log. Now we have used natural log in Chem 2 and physics, but we've never really discussed where it came from. And it turns out the letter E is also called Euler's number, E-U-L-E-R. Euler's a Dutch scientist and mathematician who came up with the concept of the logarithmic value of 1 over x has to have a number, but it doesn't work out. So he was the one who came up with E for the answer for something like that. And it comes out to be about 2.72 for whatever reason. But so what we're going to get into are the basic rules for that, and then we're going to follow this up with derivatives in the next lesson. But just very quickly, the definition of the natural log function is the natural log of x is the integration of 1 over t dt anytime x is greater than 0. So the domain of the natural log function is the set of all positive real numbers, hence the x is greater than 0. Properties of the natural logarithmic function are the same as what you expect for logarithmic values as well. It's exactly the same idea. The domain is anywhere from 0 to infinity, and the range could be any real number. The function is continuous, which we talked a lot about in chapter 1. It is increasing always, and it has a one-to-one relationship, which means that the horizontal line rule follows for it. Theorem 5.2 deals with the different properties of logarithmic values, whether they are natural or even regular. It's exactly the same thing. When you multiply two exponents or bases with exponents, the exponents themselves get added. And since natural log means the natural exponent, base e, then the base is e, the exponents are ab, and then you're going to add those logarithmic values together, exponential values together. If you were to take two values, like a power of a power is what we call it when I taught algebra 2, then the power of a power simply means then you're going to multiply the two exponential values together. In other words, like a squared to the third power in quantity would be a to the sixth, because 2 times 3 is 6. Same thing here. These are two exponents being multiplied together. In the case of division, you're going to subtract the exponent. So nothing new there. You've done this all before. It's just now that we're really focusing on a different base rather than 10. And that is E, 2.72. The definition of E, like I said, we talked about that, what that is, and the inverse relationship between E and the natural log is the following. The natural log of e to the x is x, because natural log means the exponent of e. Well, the exponent of e here is x, therefore it's x. And then if we do the same thing that we always do with logarithmic values, changing them to exponential values, this is what we end up getting. So e to the natural log of x is always going to give us x. So let's take a look at some problems that are going to involve that. So, since e to the natural log of x, well, the exponent here is x, so the answer is x equals 4. For number 3, that was that simple, yeah. And these problems are asking for values, and we're going to go 2 decimal places, or 3 sig figs with all our values for this. Number 3, the problem is e to the x equals 12. So we want to get the x out of the exponent of that. So we're going to take the natural log of both sides. So that leaves us x over here, because this is log base e, or the exponent of base e. Well, the exponent of base e is x, so x. And in our calculator, the natural log of 12 is 2.49. So there's our answer for that. Real challenging stuff, eh? Number 5. Now this is all on page 356. I probably should note that. So this is page 356 that we're doing right now. All right, continue on with number 5. Problem is 9 minus 2 to the x, e to the x power is equal to 7. So what we want to do is isolate e. So I'm going to move the 9 over here by subtracting. This gives me a negative 2e to the x equals negative 2. Divide both sides by negative 2. E to the x equals 1. We really don't have to do the next step that I'm about to do because we know that anything to the 0 power is 1, so the answer is going to be 0. But to prove that, I'm going to take the natural log of e to the x equals natural log of 1. So x equals the natural log of 1, which is 0. So that's the answer for that. If in fact you plug that in, you can see 9 minus 2 times e to the 0, which is 1, so is 7. 7 equals 7. So that is proven. Number 7. 50 e to the negative x equals 30. So just like any algebra, probably want to clear out the variable by itself. So we divide both sides by 50. So e to the negative x is 30 over 50, which turns out to be 0.6. So we take the natural log of both sides. Natural log of e to the negative x equals the natural log of 0.6. And the exponent of e here is negative x. And we punch that out into our calculators. We get a negative 0.511. Multiply both sides by negative 1. And x equals 0.511. Okay? Number 9. Problem here is the natural log of x equals 2. So to get rid of the natural log, I take e caret to both sides, because e is your base of your natural log. That means that leaves us x here, and e to the second power is 7.39. Now, the next problem is kind of the same as this, so I'm going to do this side by side. This is number 11, and this is the natural log of x minus 3 equals 2. So like I said, it's virtually the same problem, except now you got something in the parenthesis here with the x. But still, same thing. E caret, x minus 3 equals e to the second power, which we said is 7.39. So we add 3 to both sides, and round off to 3 sig figs, x equals 10.4. Yeah, it's not too bad. Number 13. This is the natural log of the square root of x plus 2 equals 1. Alright, so again, I need to get rid of the natural log, so we're going to take e caret to both sides. And this gives us the square root of x plus 2 equals e to the first. Well, e to the first, you punch that out in the calculator. By the way, to punch out an e on your calculator, I probably should have mentioned that in the last problem, kind of important. You see in your calculator an ln key, and right above it is e caret. You hit second ln, and the e caret pops up. So hit e caret, and then punch in 1, and you get the value of the natural log, which I said is 2.72. It's an irrational number, so it goes on and on and on in random ways. It's like pi in that respect. So now to get rid of the square root, we square both sides. And we get x plus 2 is equal to 7.39. Subtract 2, you get x by itself. And our answer is 5.39. And that's all there is to it. It's exactly the same as all the other algebra that you've done, that you've gotten better at since you've taken this class, that you've become expert mathematicians because of this class. This should be fairly easy for you to do. I don't mean to put any pressure on you because I know some of you have math anxiety, but I like to think the math anxiety amongst most of you is pretty much dissipated. You guys are experts now. So, your assignment. Page 356, 2 through 14 even. Have fun.